think that one of the most interesting things that I see these days with AI, it's this AI that you start to connect to real systems. And maybe the first example that you're seeing is that computer operating AI. It's very experimental, even though ChatGPT kind of like did that with a browser operator, which is starting to get interesting. But OpenAI, Anthropic actually did it a bit earlier, and they released this like conceptual demo to their GitHub. Maybe before you're actually going to talk about what it does and what are the limitations, how to make it work well, let's talk about what it is. You're basically taking an agent and you're giving the agent the access to tools. And these tools just happen to be operating a computer. Stuff like get me a screenshot of what you have on the screen, type something on the keyboard, click on something on the screen. And as you get this, you basically are letting the AI control the computer. And that actually opens a whole set of possibilities for your AI application. Now, what we've seen in order to make it work well is that it's quite tricky, and there is a reason why Anthropic treats it as like a conceptual idea. First of all, in this example that probably is going to run in the background, what you will see is that we wanted to find out who is this TensorOps CEO. It's Claudio, by the way, and this is an operation that would take a person about 30 seconds to achieve. You would probably either go on LinkedIn and you find out exactly and very immediately, or you just type it on Google. And today with the AI search, it will just pop up. It took 3.5 minutes for the AI in the example that I sent you to actually go and achieve that operation, which is fairly slow. And if you think about how much it costs, it was also about something like 25 cents, which is also quite expensive to perform. So in order to really make it work, you need to achieve a few things. So first thing is going to be performance. And we're going to talk about, quantized LLMs as a solution for it, and optimized LLMs, fine-tuned LLMs that can take screenshots and understand very quickly what's going on with it. Maybe transcribing some text so to make it, act faster when you actually need to extract text from images. So that is like one domain that you need to invest in if you're going on this direction of computer operating AI. Second, in the Anthropic example, also the one that you're seeing, that we just forked that and made some adjustment to make it work in different LLMs and change some of the tools, but essentially it remains the same. One of the things is that they insisted that you're not going to give it access to your computer. And the reason is, think about how much access you're giving to somebody who's working on your computer, right? It has access to your Gmail. It doesn't need to put in the password when it goes to your Gmail, because it assumes that if you have access to the computer, you are the person who is authorized to make these actions. So it might actually save some of your, your credit card details and sort of credentials to very, very sensitive systems. So, when you're trying to work with the system, AI can be fooled. AI can be exposed to prompt engineering or to prompt injection. And that is quite dangerous if you think about it. So you do want to architect the system to have just enough privileges to perform the actions that it needs, but not too much. Because if you do give it too much, then you can actually cause some serious disasters. And I don't want to be scaring anybody off, but you can think about what would an AI do if it would interact with a page that would somehow understand that it's talking to AI, that an AI is operating, and would inject something through the image or through the prompt that would be translated into instructions back to the LLM, and the LLM would just start to change its course of actions and do stuff with your credentials while it has access to your computer, which is, at least for me, it's like my life. So that is just the second part. The third is that very often it goes, there is context to it. And the context is, you are trying to do that because you're trying to optimize operations. And we have seen that optimization of operations is very, very often the most successful implementation of AI. So I'm all for it that you're going to try to use AI to operate computers to achieve operational efficiency. But it might not be as naive as you think initially. And maybe if I'm thinking initially about this, the idea would be, right, I have this person who is classifying invoices, and I would just sit on my email. Whenever I'm getting an invoice, I'm just going to download it using this computer. I'm going to classify it, given the instructions that I give, and I'm going to, upload it. So it turns out that, as you can see in these examples that, again, like I said to you, very often the AI gets stuck. Maybe it's a CAPTCHA, or maybe it needs some privileges that I do not want to give it. So very often you need to have a person, operating it. And even in the demo that I'm giving you, the basic assumption is that there is this chat that you see on the left, and a person is giving context and consistently monitoring the operations of the AI and explaining it what are the tasks. So if you're building it, you need to think about context engineering. Context engineering would be part of what your engineers are going to do. They're going to build MCP, and they're going to build RAG, and all of these tricks that help AI agents operate efficiently with enough context, which is engineering work. But you're also going to need to do operations work. You'll need to tell the people that are currently classifying invoices, your work is not done. It's going to change. You might need to change the quantity of people that you have, but you might need to do some adjustments to the way that they do the work. Maybe they're now on call for whenever the AI gets stuck, and all of their purpose is to just be the human in the loop. So that might be it. Another thing, you might think it's a 1 against 1. You're going to take one agent and you replace one human. But as you know, these agents might fail. So you can think about like some genetic algorithms that you give mutants. You create 10 instances of these agents and you let them run, and you have some verification. So when it gets stuck and when it diverges from the original task, you have some supervisor that basically kills it, and you're increasing the chances of it happening. So it's not necessarily, again, like one agent that operates on your behalf that's going to replace some human. It might be more complicated than this. But still, I think that through proper fine-tuning of the system, prompt engineering, context engineering, system engineering generally, choosing the right tools, the right LLMs, the right size, optimizing latencies, and adjusting your operations, you could achieve stuff that is going to give you a significant edge versus your competitors. And yes, this is one of the hot topics they're going to see, in my opinion, in the upcoming few weeks, few months, perhaps. Nobody can anticipate, right, the velocity in which AI is progressing, but I do think it's very important to keep track on this development.